Okay, this is my second time doing this problem. I went through the whole problem before and realized it wasn't recording. So, take two. I've had some questions about number 64 from a homework assignment that I assigned you a while back. The answer isn't in the back of the book for these, so I wanted to take some time to go through it. Now, this one involves two people who are taking the ACT. They agree that if one of them scores 5 or more points, or 5 points or more better, then the other one's going to have to buy the other one a pizza. Now, we are assuming that they have equal ability and that each score varies normally with a mean of 24, and a standard deviation of 2. And then we know the scores are independent. We're trying to find the probability that the scores differ by 5 or more points in either direction. That's a key word there, either direction. Which means Fred can have 5 points more or Leona can have 5 points more. Alright, so what you notice I did here was I drew a nice normal distribution representing Leona's score as well as Fred's score. You'll notice that they are both the same normal distributions because same mean, same standard deviation. Now, the thing is, I'm trying to find the probability that their scores differ by 5 points or more. Now, if I'm looking for the difference in their scores, I got to figure out what the expected difference is. Now, Fred's mean is 24. Leona's mean is 24 as well. To find the difference in these are their expected scores, right? So I want to find the expected difference. So all I'm going to do is subtract them, and I get 0. So I'm expecting that they're not going to have any difference. Now, for the standard deviation, you're not going to subtract these values. A lot of people would assume that you just subtract the standard deviation of 2, do 2 minus 2, you get 0. And then but Mr. Gamache, that means there wouldn't be any difference. Here's the thing. When you're finding a difference of 2 random variables, you have to find their standard deviation. You can't just subtract them. You got to find the variance first. So, to find the variance, I'm going to have to combine these. So, standard deviation of 2, to find the variance, I just square it. And even though it's a difference, remember, I'm going to add these. Even when you're finding differences, when you're combining standard deviations, you add them. So I'm adding 2 squared plus 2 squared, adding my variances to give me my combined variance. 4 plus 4 would give me 8. So that gives me the variance in their scores. But I don't necessarily need the variance. I mean, the variance is great, don't get me wrong, but ultimately I want it to lead to my standard deviation. So now to find that standard deviation, I just got to find the square root of the variance. Square root of 8 here is 2.83. I'm double checking that. I'm like 99% sure because I've done this. Yep, 2.83. All right, so now I know my standard deviation for my difference here. Okay. So now that I have this information, I'm going to draw a new normal distribution. Now, this isn't... I'm going to do a quick one here. Normally, I should add in a number of values here, like I always tell you guys. But for sake of time, I'm going to make this a pretty basic normal distribution. Now, my expected difference is 0 here. My standard deviation is 2.83. And that means if I'm 2 standard deviations away, that's going to be 5.76. And going away from it, negative 2.83 and negative 5.76. All right, so now we're concerned about 5 points or more in either direction. So again, it could be if Fred scores higher or Leona scores higher. So I'm looking for that 5 or more. Now, we know that this is definitely above 5. And I can even kind of say like right here. And this might be 5 less. And all of this stuff right here. So just looking at my normal distribution here, I can already come up with a basic approximation. So I know that 2.5% is found in either of these directions. I know my answer is going to be at least 5. And then I have to include this little piece right here. I could guess that maybe those represent maybe 2%. I don't know. I'm just approximating here. So I'd guess maybe my answer would be close to 9% probability. That's where this visual can come in, because if I enter in something wrong in my calculator, or I do something that's a little bit off, I can come back to my drawing here and say, is this what I'm expecting to see? If it isn't, then I can try a different strategy, like maybe use a table or something. All right, so now I got to figure out this exact probability because this isn't enough. All I did was I used my visual to kind of get me in the ballpark. So what I'm going to do is I'm going to use norm CDF, and I'm concerned about going to the left and going to the right. Now, guess what? As you can see, this is a symmetrical distribution, a normal distribution, which means this area here and this area here is going to be the same. So technically, I only have to do it once and double it, but I'm just going to do it twice and show you. All right. So for my lower bound, I'm going to start with on the left side here. I'm going to go with like -9999, enter a bunch of 9s. And I want all the way up to -5. My mean is 0, standard deviation of 2.83. And when I plug that in, I'm going to get 0.3863, whatever. I'm going to go with 0.039. Okay, so I'm halfway there. I got to find the right side now. So, I'm going to go norm CDF again. Now for this lower bound, since I'm going over here, I'm going to start with 5. For my upper bound, I'm going to go with that high one, 99999. Mean 0, standard deviation 2.83. Plug it into my calculator. You can even check it along with me. And you're going to get, ta-da, the same exact value. And I'm going to round it in this case to 0.039. Since I found that this area is 0.39, this one's 0.039. Excuse me, I should have said that previously. Add them together, and I get 7.8%. Pretty darn close to that 9% guess I made here. So that's where this visual can come in handy. Because if I got an answer like 50%, 80%, then I would have known I did something wrong with my calculations. So the probability that their scores are going to differ by 5 or more points is going to be 7.8%. So the key to this problem was realizing that we are looking for a difference. So I can take the means of the two of them, subtract them since it's a difference, and that gives me the expected difference that I get between the two. So that'd be 0. And another key part of this problem here is, too, when you're given standard deviations, you're trying to find a difference between two random variables, you gotta find the variance first, and to do that, you add. Very common that people would want to subtract here, but you do add. Add to find that variance, find the square root of the variance, and that gives you the standard deviation of the difference of those random variables. As always, if you ever have questions about these problems, you can always come to see me. But hopefully this helped today. Whoops.